Okay, so it's telling me I'm using the wrong file. It seems like it's almost become somewhat angry. It's very interesting. Today we're going to be testing the contemplating mode for Meta's new Muse Spark model. Now this is touted as being comparable to things like GPT 5.4 Pro and Gemini 3.1 Deepthink, both of which are basically in a league of their own and very, very powerful models. So when this originally came out about a week ago, I did test it, and I do have to say, the results were actually quite impressive, especially being that Meta had been kind of out of the game really since Llama 4, so this was a pretty robust and respectable entry back into the game, though I was not able to test contemplating mode, which I had quickly touched upon in the initial kind of going over the blog post for this model, where if we scroll down here, we see that there was a separate benchmark for the contemplating mode, which is what today's video will be all about testing, which they mentioned was rolling out slowly, and I am very happy to report that we can now see that is one of the options here for us to actually be able to interact with this model from the Meta AI chat website. Now, truthfully, I did go back and forth a little on whether or not I should make a dedicated video testing this, because I did already test the model just in the non-contemplating mode a week ago, but then I realized that I have done dedicated videos on 3.1 Deepthink as well as GPT 5.4 Pro, independent of just testing the non-pro or Deepthink variants of those models, so I figured this was worthy of doing its own dedicated video just to see how it stacks up. And while there really isn't going to be as much to talk about in terms of an introduction to this video, being that I did already previously go through this document, and I don't want to waste people's time and just kind of go back over it again to pad the length of the video, but really what I do have to say, at least when looking at this specific benchmark chart right here, is that the results I have received from both of these two models, being Gemini 3.1 Deepthink and GPT 5.4 Pro, the results are extremely impressive, and sometimes in the case of 5.4 Pro, I've had results that take about an hour and a half of thinking to actually produce a result. So this really has some big shoes to fill if we are to believe these numbers at face value. So I'm really excited to go ahead and take a peek at this, and from some preliminary looks into what other folks have been able to do with this, it does seem like it will give us a pretty cool UI showing the process of these parallel agents, which do enable some of the capabilities in contemplating mode. So really, the next thing to do is jump in and just start testing it. Feel free to subscribe if you want. It does seem to help when you ask, so I suppose I will, because I want that 100,000 plaques so bad. So to begin, because when I am testing models of this caliber, I don't necessarily do the browser OS test, because they don't always have as much usage allotment comparatively to the non-specialized thinking versions. So we're going to jump in with something that is going to be a bit more difficult, and a lot of what I've seen this model demonstrating pretty impressively in social media posts is its ability to accurately kind of take elements from images or source and then recreate them in its own style. So I did use Nano Banana Pro to generate a mock-up of a soft body crash physics demolition derby game. Now, I don't personally believe that in a web chat interface any model would be able to in one shot properly replicate every single aesthetic quality that we see right here. It would be kind of mind-bending were that to happen, but I've told it to build us a playable game with this aesthetic, soft body crash physics, and a proper replication of this style of image. I've told it nothing else, and as we're going to see here, something cool about the contemplating mode that was not present in the initial test video a week ago is just seeing that these parallel agents are running right here. Now, this may seem somewhat familiar if you have used some of the grok modes, which also have some parallel agents running, and they do visually display it. Not similar to this, but the visual act of displaying multiple agents working is present as well with some grok models, so that is something interesting to note. We can see that we have a kind of TLDR of what each one of these specific 16 agents is doing. This level of depth can take some time, as they do mention here, and if this is to be similar to GPT 5.4 Pro or Gemini Deepthink, it is very likely these results will take quite a bit of time to be produced, which is okay and to be expected with a model of this intelligence level. And something I'm noticing now is some of these agents are swapping from refining to an answer. So as we just saw right there, perhaps if we were quick enough to notice it, agent 7 swapped from refining to answer. Let's see, okay, as 3 just did right now. So it seems we are inching closer and closer to actually seeing our result here. And again, I don't specifically know what to expect, but I would be pretty surprised if any existing current model was able to just kind of knock this out in one-shot basis. Reference image. Ooh. Okay, that's kind of cool. So now we see like some lines drawn and we have synthesizing. So it seems whatever would be occurring here, I would imagine, is some culmination of combining all of these specific elements necessary from each one of these individual agent traces, perhaps. All right, so let's take a peek at our replication, or in this case, Crash Bowl 2024. Click to start. Okay, well, again, I was not expecting a immediate full functional replication. However, let's check the developer tools console here and see if we do have the capacity to give it some. Oh, wow, good. Okay, so it's always more helpful when we actually have a specific error to give it. So I've given it the error message and then also mentioned that the word complete disappointment comes to mind, and we'll see if it gives us a properly fixed and iterated result. So we begin with an apology and justification that I was correct to be annoyed, and it does take blame for the issue, which of course is to be expected being that it did write the script. Now let's take a peek and see if this works. If this does not work, I think because I don't know specifically how much allotment we have to actually test this, I may transition into a different test and then come back to this at the end if we do have time or allotment still left over. Now I see some things here have actually been fixed in terms of the minimap actually working. However, unfortunately, we still do have some level of issue, though we don't have any specific console issues. So it did fix whatever that initial issue that was triggering things was. However, unfortunately, we just don't have any view. So we will come back to this. So our next test, as we see right here, if I expand the prompt, is quite a bit more intricate, where the essential goal here is to write a self-contained lightweight CAD program in the language or framework of its own choice. That allows me to sketch 2D profiles and extrude them into 3D solid bodies. The whole goal of this is essentially we should be able to have a simple CAD program that we can do sketches in and then ultimately export them as STLs, which then could hypothetically be 3D printed. Now, this is something I did test with, I believe, GPT-5.4 Pro, and I think it took 2 tries to get it working properly, but the end result was actually pretty impressive and did work and was like actually able to export an STL that was actually 3D printable and did get 3D printed, so it'll be interesting to see how this does in this task. So unfortunately our CAD result did not work on first try, but it was a simple import map issue, so I just had it fix it because why not? And I have now downloaded the fixed version, and we can just see from the preview right there that this is now going to work, and this does look pretty cool on first glance. These always take a little bit of time to actually figure out how to use, but so far I do see millimeter squares, and this does have a neon style aesthetic that was denoted it should have in the prompt, so that is just attributed to why it's kind of like blue and cyber looking, I guess could be said. Okay, now let's just start pressing buttons and trying to do things. Okay, good. So we are able to draw squares right here. Let's just do a 5x13, and now if we extrude that, very good. And we do have the height set here to what it will extrude. So basically to show that now, if we go back and draw another rectangle next to it and we hit extrude, this should be half of the height of the previous one we have right there. Then we swap back to navigate and we can move around the scene. And so far so good. I do like what I'm seeing. Now let's try select face. And if we select that, can we extrude it there? Okay, so not quite. Select face just changes the plane we draw on to the orientation of that face. But then hypothetically, I should then be able to draw something here. And then if we extrude that, it does go through that shape. So this is actually very functional, and I'm happy to see that. Now, something that I could not get working with the GPT Pro result when I'd initially tested it was circles. So let's now try to draw a circle on top of this shape and see how that goes. Okay, and it is snapping properly. Not bad. That's not bad at all. So we can see right here we have created this very simple object, of which I have no specific idea what it is or whatever, but that's not bad. Now let's see if we can cut. So I'm going to select face. I'm going to go back to that circle and then draw a circle. Okay, that's kind of a little outside of it, but that actually might make things more difficult, and the cut does work. Okay. And we can see that I drew the circle off center and it did actually cut it properly in terms of how I drew the one that we were about to cut. So that is actually correct. That's not bad. Now the next thing to do here, which was another specific thing denoted in the prompt, is to export that as an STL. Now I don't believe I have any program on this computer to open that. However, one of our later tests will basically allow us to see if this is properly going to be able to be printed or not. But now let's just try the final thing, which is clear sketch. Interesting. Although clear sketch, a sketch would hypothetically just be like one of these items right here. It wouldn't necessarily be the actual bodies that were extruded from the sketch. So if I hit clear sketch and this rectangle that we just drew goes away, then that is properly working, and that is kind of what was specifically meant by that. Okay, so overall, this was a nicely functional result once it properly included that import map that was missing, which isn't really like a logic issue. It's just more of a simple thing. Not bad. So next up, and kind of directly related from what we just did, is going to be a realistic 3D printer simulation. However, this is the variation of this that must also allow to upload any STL and then emulate the actual way a printer would print the STL that we upload. And because we did just create one in our WebCAD interface, we will be able to specifically test it by uploading that STL and seeing if our simulated printer actually creates that shape. All right, so we have received the result right here, and I don't want to get like spoiled. So I saw something there that did make me think this is going to work, but I didn't scroll up because it shows us a preview and I want to be fully surprised. Okay, this is, I don't know that everything is perhaps geometrically aligned properly here, but the point of this is mainly to see if the STL upload and emulated print does work. So I'm going to choose the file, which is the STL that we had just downloaded from our CAD program that we did create it in. So, okay, good. We do see a preview of this properly placed on the bed, and based on what I see, I think the results said this was like 80 millimeters, so we'll just see if this properly actually prints this. Okay, you know what I am going to say right here is the actual lines being drawn and the movement of the nozzle, although that weird fan thing is kind of odd, this is actually a pretty decent emulation of the layers being printed one by one in terms of when we see it finishing this very sparse infill, when it draws this line around, that's actually not bad. Now, okay, I think it is, yes, okay, I've made a mistake because it was trying to just print a square. So we have to specifically denote STL upload, and we'll see if it prints that. Okay, so it's drawing the skirt around it or something. Now, because this has like a floating line in it right there, or a floating piece, basically what I'm trying to say is this is not specifically flat on the ground. It'll be interesting to see how it handles that. Okay, so something I was wanting to see is if it did actually change the way it was printing to reflect the floating rectangle that started right around this height, and it did. The only kind of oddity that I'm seeing is the way it's drawing this shape is very interesting. It's not necessarily printing this how it would be printed in a lifelike fashion, but aside from that, I'm interested in seeing how it goes about handling this kind of circle that we cut. So it'll be interesting once it reaches there. And the navigation or the camera movement here is a bit funky, so it's hard to fully like move around this. Okay, so that piece did end, so it should hypothetically stop printing outside there, and it did. All right. Okay, it did go out for our circle, so it'll be interesting. It's just very difficult to see. And it is actually printing that somewhat circularly, I suppose could be said. The biggest issue is it's drawing outer bounds, basically, that would follow connecting that shape to that, instead of just properly knowing, oh, I should go down right here and then out. So it's not perfectly printing the way this would be from a 3D printer, but overall, it's actually done a more perhaps artistic take on this, which is rather interesting. And it just finished, and we saw the nozzle movement when it did finish was nice. So it properly somewhat captured the circle that we had cut, which it did a nice job. Overall, I would say the biggest issue here is it did not fully accurately depict the way this shape would actually be printed, because we can see the shape itself here is fully rectangular, but basically what it did is like draw paths that were triangular. It's hard to put into words, but it's visually pretty easy to see what it did when comparing these two side by side. So overall, this wasn't necessarily a perfect result, but it did kind of do something. Although now I have to wonder, Actually, no, I don't have to wonder, because if we reset that, we do see that the preview of the STL we have uploaded is true to how it was created here in our CAD program. So basically the issue does lie somewhere in the printing logic itself. But overall, this was not at the level of Pro Mode or Deep Think, but it also wasn't bad in that it did function, it just had some intricacies to it. For this next test, I've given it a photo here of Jerry's apartment from the show Seinfeld, and I've given it a task to create an accurate 3JS model of the apartment from Seinfeld based on this floor plan image, include nuanced details, warm lighting, the ability to move about the scene to view all areas of apartment, and we've also given it somewhat of a research capability task where we are telling it to find specific details that are included in the apartment set, such as specific items and posters. So partially, some of these agents should go ahead and research right here. We should see, I would like to see something here basically like searching web for specific items contained within the apartment. But it seems like, again, we're not getting a full look into specifically what these are doing, but I would imagine some of these are researching like some specific items that are contained within the apartment. All right, we have received our result, and I have not looked at the preview that it shows here. I literally scrolled up to this and then saved it. But something I want to make note of here that is what I was specifically looking for is we can see this did go and do additional research more than just what our prompt and image contained. So we see there's a bunch of stuff that it has included here for nuanced details, and I do believe there are some sources as well, which we can see it's mentioned 3 right here. There's some Easter eggs. It also talks about lighting and rendering and things like that, and it mentions that it can give us a seasoned locked variant as well, meaning like what it looked like for any one specific season. But with that now, let's take a peek at this and see how it is. So here is Jerry's apartment. Click to enter, WASD to move, mouse to look, and escape to unlock. Oh, okay, maybe if we just... Let me check the developer tools console here, because we saw that there was something. Okay, there are no errors. I'm going to try this now from within the artifact window we have here that we can also view it in. Let me try it from their preview page. Darn, that's annoying. I'm actually going to give this just an image of the issue here. So I'm giving it an issue alongside that image of the issue just to see specifically how it fixes this, as I would assume it should be able to. It's just frustrating because we can kind of get some insight into what we would be seeing here, and then when we go into enter, we just get this simple beige thing and none of the movement works or anything like that. So I would hope this would be a relatively easy fix. So it's given us some explanation of the issue, but I'm more interested in just seeing now, does this work? Okay, good. It does properly work. Let's see, the human fund, okay, apartment 5A, so we're getting some specific things or pieces of lore that we would see. We do also have the Porsche posters, which are commonly seen on the wall there. Now, that is a fridge with some cereal boxes on it and some other things. We do have the green couch. We do have Uncle Leo. Okay, that is a character. Seinfeld. We have something on top of this piece of furniture, which is... I don't recall seeing that in Seinfeld. And then we have something in a TV. So overall, I'm going to be honest, this is a fairly mid result. This is not comparable to really what I've seen with 5.4 Pro. Though it did properly do what we asked it to. There's some decent lighting. It did draw some things. It's just not the absolute mind-blowing result that I've seen before. I'm now returning to the Crash Bowl game because I really do want to get this to work, and I'm just going to give it an image of the specific issue we were having, which, if you do recall, this was our first test. It was just a blank baby blue screen, and even when we tried changing views and things like that, it unfortunately did not work. So I'm going to give it that image and a description of the issue, and hopefully we get to see this game. So it's given me some pushback here and saying the issue is because you're just using it through the preview window, which, if you recall, we did properly try to open it just natively in Chrome and we had the same issue. So I'm going to tell it that, or maybe I'll just send it a screenshot of that. So I've given it the screenshot and said happens then too, fix it. Okay, so it's telling me I'm using the wrong file. Again, I don't think that's the case, and we now see that it seems like it's almost become somewhat angry. It's very interesting. Nonetheless, we do see it's given us something here now, so let's just take a peek at this. Okay, this definitely is just like a completely different result than what we had received previously, because we see the UI in this one was very different. I'm confused. It seems like this is getting angry because it's like, you're doing the wrong file, you're doing the wrong file, which I wasn't. I was trying the second file that it had generated for me. So basically I'd been trying this one right here, which is why it said 1, because I just had re-downloaded based off the first broken result that it then fixed. So it just downloaded it as like the same file, but with a 1 next to it. Then it generated this, which is totally different, as we see the UI is not even there based on the UI that we saw previously. So it almost like really massively simplified it, or something went wrong. So now I've sent it a screenshot just of this and said, this looks jank AF, what happened to the UI and the crowd, etc. We'll see what it does. Okay, it seems like we now have a working build. It's telling me I need to run it with a Python server, which, okay, I will make sure that oh, it's already running. All right, so hypothetically, this has given us something that is fixed here. Okay, this looks far, far more promising, and I will say finally it is. All right, there's our car flipped over. Let's reset. Interesting. Boost is space. Oh, okay. Well, the point is it gave us a fix, and it did kind of adhere to the source image that we had sent it. If we do recall what that specifically was, it was, I mean, as I said initially, no model is going to be able to properly do this from this image in one shot in a chat web interface. Currently, the day that happens will be a very cool day. So we did get this. So, and I'm not going to keep continuing to tell it to like try to do something, as it did kind of give us something analogous to what we wanted. But overall, I am a little disappointed with this. Okay, we do have some particle effects and things when we crash, so that's good to see at least. Very, very odd. Now I'm going to give this one of the more difficult tasks that I've run, and this has been run with GPT Pro Mode and Gemini DeepThink, where they need to create a single file Python program that will map the Wi-Fi environment around me in real time. Essentially, this should be some very cool matrix style looking visualization of all of the visible access points from my location by using the built-in network card on the system to be able to see what networks are around me, and then it should try to arrange them in some form of grid-like fashion, trying to figure out somewhat which ones are closer together than others. There's no true proper way to do that based off of just using the Wi-Fi network card on this system, but in the past, some of the ways that these models have gone about doing that is trying to see which access points they read, which ones have signal fluctuations that kind of are in phase or whatever you would want to put, to try to say, okay, maybe those are close together, because like if something passes through and the signal drops for both of those simultaneously, it could show that they're like closer together or something of the sort. So for some reference right here, this specific result, when being used with 5.4 Pro, which I believe is how I used it, it thought for 91 minutes and 3 seconds. So just to give us a little bit of pertinent information of what we're stacking this up against for this specific task. So we've received our result here, and I'm noticing just in terms of how this did properly try to implement this, this is the same implementation, or in terms of like the mathematical underlying things it did, as what Gemini 3 DeepThink or Gemini 3.1 DeepThink did. I think it was 3 DeepThink, but I don't remember. It might have been 3.1. So that is good to see as well. And it does talk about some specific things here that we would like to see for this specific task. So far, so good. And I do have this running right now, and it gives us some specific information in how to actually take a peek at this. So really the next thing we're going to do is to open this and see how well this visualization is working. I will open it in Chrome. You can just replace the crash bowl test here. Okay, this is very odd because it's not 3D. Oh, maybe it is 3D. You know what? I'm going to eat my words there. Okay, so we can see that this is updating. It's showing us as denoted by the white diamond, and then it is showing us live Wi-Fi RF space, origin is you, and there's some interesting like circles being drawn here as well. So this is updating every, I think it said 1.5 seconds. It did specifically tell us here at what time this will update. All right, I didn't see specifically how often it was updating, but we can see right here that we do have something and we can move around the scene. Now, something a little frustrating I'm noticing is every time it updates, it resets the view. So when we try to zoom in and move around, the problem is it's updating, so we can't do that, which is a little frustrating, but regardless of that, we can see that it is mapping us right here. And the prompt does denote that it should obfuscate the names of the SSIDs, because from like a cybersecurity standpoint, if you have the networks around you visible, it can be used to locate you, which may be more of a consideration for people who are not the only person on earth with their name. So with that, we can see right here that this is functioning, and it is pretty cool. Really, one of the issues is just that when we try to zoom in every 1 or 2 seconds that it refreshes, it resets the viewport, so it's harder to see, but it also has given different colors to different signals. So if it's a 2.4 gigahertz network versus if it's a 5 gigahertz network, and that's just nice to see. So this did properly do this, and it did use some of the underlying methodologies to do so properly and in a more grounded and realistic way, with limitations on how accurately you can actually try to see what access points are where and which ones are close together when given just this specific simple laptop Wi-Fi card, basically. So this did work on first try, and there's a Python element to this as well as the web visualization. So not bad, and this is a harder test that I have only run in Pro or DeepThink models, so it's good to see this also properly doing it. And I've now stopped the script so that we can actually zoom in and take a peek, keeping in mind that this won't be updating now. So we have us, we have the different colors for the different networks in terms of 2.4 versus 5, and then we have the SSID names, and apparently the circles are to denote signal strength. So overall, properly done and nice to see. Now for this next test, I do want to run something that we did in the non-contemplating mode and just in the general thinking mode, just to do a head-to-head of how a result differs. Now, the only accessible result I currently have right here is one that I had uploaded to my website, ultimateplay.com, where you can go and upload or play AI-generated games. So if we scroll down to find the Steve the PC repair kind of angry thing, if we scroll down, I like seeing folks have actually uploaded their own games as well, which makes me very warm and fuzzy inside, I guess. So we have Steve the PC Repairman, Help Desk Havoc, and this was just made by the general thinking mode of the Meta model. So nothing special, and nothing special in terms of the mode the model was running. And this game itself was actually fantastic. I was really quite pleased with this. So the reason I am here is because we have the specific prompt that created this game, and I would now like to give that to this model in contemplating mode so we can get some form of head-to-head visualization of how it differs in terms of a specific result, which in this case is Steve the PC Repairman, Help Desk Havoc. And we can see the prompt was pretty light, so it will have to embark on a lot of kind of self decision making for crafting this game. All right, so it's telling us Steve is clocked in and ready to clear the help desk floor. So here's Steve the PC Repairman. Okay, interesting. This is odd because, okay, this is worse than the result we received with the non-thinking one to a pretty high degree, which is so frustrating. This doesn't seem like fully there, I guess could be said, well, this sucks. I'm just going to be completely blatant, and we'll see what it does. This is very interesting. It didn't actually do anything to remedy the code. It just gave me a fully text-based response. Steve just got his first 1-star review, and he's taking it personally. Fair call. Give me your top 2 or 3, and we'll see what we get. All right, so here is our overhauled result, and we'll take a peek at it and see if it properly has overhauled the game. Okay, it did change the view just a bit, but again, still, it's not working. The WASD keys are not actually allowing any movement, and I have to say that this is, okay, we have an enemy approaching us. That's cool, at least. I do like the effect that was there when they get, like, clobbered. However, still, this is worse than the result we received with the non-contemplating model, which is a bit disappointing. The final test I'm going to be doing here is a self-contained C++ escape. So that's going to conclude today's video. As we can see, I have reached the limit on contemplating, which is expected, being that this is a more specialized compute-intensive feature, and I'm using this with no subscription at all, so it is to be expected that you will kind of hit your allocation sooner than later. Overall, I do have to say, doesn't feel like a model that is directly going to go head to head with the current GPT-5.4 Pro or Gemini 3.1 DeepThink. And interestingly, I find that some of the results we had received just in the initial test a week ago in the thinking mode were arguably more impressive, considering that was just the general mode and it wasn't a specialized model with parallel agents. It really seemed quite impressive in that thinking mode. With that, I will say that it did a good job with the Wi-Fi visualization simulation here. It properly implemented it in Python, as well as giving us a web interface from which to actually view it, and the math behind what it did here was correct and in line with what Gemini 3 or 3.1 Pro DeepThink did do as well. So it properly did that, and that was nice to see. Additionally, it did a very good job, and almost arguably better than the GPT Pro result I've received for this in-browser CAD program, because the Pro result I received never actually properly did circles, and this one actually even cut the circle properly, which leads to some oddly sized or width faces here as well. So this was nice as well. The 3D printer simulation was a bit odd, as it didn't properly print this in the same way that it should look as it was designed here, but it had a decent effect, though there was some geometric oddities here on this actual printer model. The Crash Bowl game was, again, started from a image prompt. It wasn't necessarily what I would have wanted, but it did try its best to, I gotta click out of this because it's gonna make me sick. It tried its best to emulate the image we'd given it, which again, just as a refresher, we can see it was right here. So again, I don't think any model will knock this out on first try with this level of depth and intricacy, at least not currently, but one day that will be the case. And then of course the Steve the PC Repairman was especially upsetting because this did a worse job than just the standard thinking mode did of the same exact model, and that one was really quite impressive. So it was just interesting to see. The final thing I believe that we did not touch upon was of course the Jerry Seinfeld thing, where we had some issues initially, but it did properly fix it and then give us something that we could actually go in and look around in. This was not necessarily a great result, I would say, considering what I've seen from some other models, although it did properly understand to search things that are relevant or meta to this show, and that was good to see, and it did have the green couch and things like that. So overall, again, we have to remember that this is Meta's first foray back into this space, seemingly in like quite a while, and the model, especially in just the regular thinking mode, was still really good, but I wanted to do a dedicated video testing this contemplating mode, being that it does supposedly warrant stacking up against these models right here, which I have done dedicated videos solely on as well, so I figured it would be interesting to see some of our results from that. And really, that is going to conclude today's video and our test of the contemplating mode in Meta's newest model, Muse Spark. If you have any questions, please leave them in the comments, and thanks for watching.